Hello everyone, I'm Dr. Buddhika Leyanike. Today I would like to talk about heat transfer in a chemical reactions using calorimetry. Specific heat capacity. Specific heat capacity is the amount of heat required to raise the temperature of 1 gram of substance by 1 degree Celsius. The units joules per gram per degree Celsius, or if we use Kelvin units, joules per grams per Kelvin. Q is equal m times S times delta T. Q we called the heat energy, heat absorbed or heat released by a substance, measured in joule units. M is the mass of the substance, usually measured in grams. S is specific heat capacity, joules per grams per degrees Celsius units. Delta T is change in temperature, usually measured as final temperature minus initial temperature. So Q is equal ms delta T is most commonly used equation in this heat transfer calculations. Specific heat capacity for different substances have different values. You can find these specific heat capacity values from any chemistry textbook. The most commonly used specific heat capacity of water is 4.184 joules per gram per degree Celsius. The meaning of this is 4.184 joule amount of heat required for 1 gram of water to increase the temperature by 1 degree Celsius. What is calorimetry? Calorimetry is a process of measuring the amount of heat transferred to or from a substance, the heat absorbed by the substance or heat released by the substance. In an isolated system, there are three types of systems we are learning in thermodynamics: open system, closed system, and the isolated system. Isolated system is no heat or no mass transfer. So in this isolated system, the heat lost by the hot substance is equal to the heat gained by the cold substance. No heat lost to the surrounding. We can write this expression as Q lost plus Q gain is equal 0. Then we can rewrite this equation. Q lost is equal, if you move Q gain to the other side of the equal sign, Q lost is equal negative Q gain. The reason is no heat lost to the surrounding. Any amount of heat lost by the hot object is gained by the cold object. Now Q is defined as ms delta T. So we can apply it for the hot object, mass of the hot object times specific heat of the object times delta T hot is equal negative mass of the cold object, specific heat of that times delta T cold. Now using this equation, we can calculate any unknown parameter during the heat transfer between hot and the cold objects. This is the content slide. This content slide, you can see there are 7 questions I have outlined here. Those 7 questions, let's go and talk one by one in the next slides. Question number 1. Calculate the amount of heat required to heat 1.01 kilograms of water from 0.05 degrees Celsius to 35.81 degrees Celsius. First, let's define what are the values given in the question. Mass value 1.01 kilograms. If we multiplied it by 1000, it converts into grams. That is 1010 grams. Specific heat of water. The substance is water here. So then water specific heat values, we know it's 4.184 joules per gram per degree Celsius. Delta T. Delta T is temperature change, final temperature minus initial. Final is 35.81 minus initially 0.05. Then the difference is 35.76 degrees Celsius. Now let's apply Q is equal ms delta T equation to calculate Q value, the amount of heat. You can see Q is equal m mass times specific heat values times temperature change. If you divide this Q value in joules, you can convert it into kilojoules. It is 151 kilojoules. Again, let's focus on the sig figs. There are 3 sig figs in the mass number and 5 sig figs in the specific heat and 4 sig figs in the temperature change. So the least number of significance we consider in the multiplication and the division. So least number is 3. Then final answer into 3 significant figures. Next question. Calculate the amount of heat in kilojoules required to heat 255 grams of water from 25.2 degrees Celsius to 90.5 degrees Celsius. Mass value given 255 grams, specific heat of water because substance is water. Delta T is final minus initial 65.3 degrees Celsius. Again, let's apply the same equation. Q is equal ms delta T. Mass value times specific heat values times temperature change. Significant figures, 3 sig figs is the least. Then final answer is 69.7 kilojoules into 3 sig figs. Question 3. How much heat is needed to warm 250 grams of water from 22 degrees Celsius to 98 degrees Celsius? Again, let's define the values. Mass is 250, specific heat, the substance is water, then water specific heat is 4.184 joules per grams per degree Celsius. Delta T, final minus initial, is 76.0 degrees Celsius. Let's apply the equation Q is equal mass times specific heat times delta T. Mass times S times delta T. Then significant figures, 2 significant figures in the mass reading, 4 sig figs in the specific heat and 3 in the temperature change. So the least number is 2. Then final answer is 79,000 joules or 79 kilojoules. Question number 4. Substance is not water. It is a silicon. A 156 gram sample of silicon is heated from 25 degrees Celsius to 37.5 degrees Celsius. How much energy was required? Specific heat of the silicon is given 0.712 joules per grams per degree Celsius. The same like before the previous 3 questions, only difference is the substance has changed here. Let's apply Q is equal m times S times delta T. Mass of the silicon 156 grams times specific heat value is given 0.712 joules per grams per degree Celsius times temperature change final minus initial, it is 12.5. So the answer is 1.39 kilojoules. Question number 5. A sheet of gold weight 10 grams and at temperature 18.0 degrees Celsius is placed flat on a sheet of iron weight 20 grams at a temperature 55.6 Celsius. What is the final temperature of the combined metals? So you can see there are 2 colors I have used here, the blue color ones for the gold and green color ones for the iron readings. Initially, the gold mass 10.0 grams and gold temperature is 18.0 degrees Celsius. It is at lower temperature value. Now, iron metal mass is 20.0 grams. Iron temperature is 55.6 degrees Celsius. And the specific heat values of the iron 0.449 joules per gram per degree Celsius. And specific heat of gold is 0.129 joules per gram per degree Celsius. Now, if we combine these two metals, cold metal, that is gold, and hot metal, that is iron, cold gold and hot iron combined together, what is the final temperature? So here, heat lost by iron is equal mass times S times delta T. The mass of the iron is 20 grams times specific heat of the iron 0.449 times temperature change. Final temperature we don't know after combine two metals minus initially iron is at 55.6 degrees Celsius. This is for the gold metal initially at 18. So after it combined with hot iron metal, it gained some heat. So heat gained by gold is equal again ms delta T. Mass of the gold times specific heat of the gold times again final temperature after combine the metals we don't know yet minus initially it was at 18.0 degrees Celsius. Heat lost by iron. After combine the metals, heat lost by iron plus heat gained by gold. Both if we add together is equal to 0. No heat lost to the surrounding. So we can rewrite this expression. Heat lost by Fe is equal, if we move heat gained by gold to the other side of the equal sign, negative heat gained by gold. Now let's equalize the first equation, heat lost by gold to the heat gained by gold. Left hand side you can see the iron information, the right hand side gold information. Mass of the gold times specific heat of the gold, mass of the iron times specific heat of the iron times temperature change is equal gold mass times specific heat of the gold times temperature difference. Now only unknown is final temperature after both metals contact together. You can solve this equation through these steps and final temperature Tf is equal 50.9 degrees Celsius. Next question. Question number 6. A 588 grams of chunk of iron is heated to 97.5 degrees Celsius. Then it is immersed in 247 grams of water. Originally water temperature is 20.7 degrees Celsius. When thermal equilibrium has been reached, the water and the iron are both at 36.2 degrees Celsius. Calculate the specific heat of iron. The same concept we used in the previous question, question number 5, we need to apply here. The heat lost by the chunk of iron is gained by water. Finally, both chunk of iron and water is coming to the same temperature of 36.2 degrees Celsius. This is heat lost by iron. Iron mass times specific heat of the iron times temperature change. Final temperature is 36.2 minus initial it was heated to 97.5. So final minus initial. The same way for the water. Mass of the water times specific heat of the water times temperature change. Final temperature minus initially water was at 20.7 degrees Celsius. Now heat lost by iron chunk plus heat gained by water both equal to 0. So if you rearrange this equation, heat lost by iron is equal negative heat gained by water. Now we can equalize chunk of iron equation to the heat gained by water equation. So after we solve, we can calculate specific heat of iron, that is SFE. It is 0.444 joules per grams per degree Celsius. Last question, question number 7. When 50 grams of metal at 75 degrees Celsius is added to 100 grams of water at 15.0 degrees Celsius. The temperature of the water rises to 18.3 degrees Celsius. Assume that no heat is lost to the surrounding. That means this is considered as isolated system. What is the specific heat of the metal? Same concept like the previous two questions. Heat lost by the metal. Mass of the metal times specific heat of the metal times temperature change. Heat gained by water. Water mass is 100 grams times water specific heat times the temperature change, final minus initial. Final is 18.3 minus initially water is at 15.0 degrees Celsius. Now the concept is heat lost by the metal plus heat gained by water is equal 0. So if we rearrange, heat lost by metal is equal negative heat gained by water. We can equalize this equation, heat lost by metal to the heat gained by water. The only unknown is specific heat of the metal here. After we solve, the answer should be 0.487 joules per gram per degree Celsius. I hope now you will have a clear understanding about what is specific heat capacity, meaning of calorimetry, and with sample problem solving. Thank you all for watching. If you find this helpful, please subscribe to the channel for more learning.